All right, so now we're going to do 4-3. We're still solving systems of equations. And this is a new method. So first video we did by graphing. Second video we did substitution. This one in 4-3 is called the addition method. I call it elimination. And that's what it's always been called up until this textbook. I had never heard of it called the addition method. So it's kind of the same thing though. But just so you know, basically what you're going to do is you're going to look at your two equations and you're going to eliminate one of the variables and solve for the one you didn't eliminate, and then you plug it back in. So let's get started. All right, so addition or elimination. So see, they even refer to it here. So we're going to solve the system by eliminating a variable, plugging the variable we didn't eliminate back in, and solving the whole system. So for example, we have this system of equations right here. So when you are solving these, you look at the two equations together, okay? So you're not going to solve one for the other variable or anything. As a matter of fact, you want them to be in standard form. So you want to get both of your equations in standard form. The x and the y on the same side, the number on the other side. And then you look, okay, I have a positive x and a positive x. I have a positive y and a negative y. So it doesn't matter about these two. You're just looking at the x's and the y's. So what I'm going to do, I want to eliminate the y because one is positive and one is negative. Because when I take and add them together, so if I did x plus x, I get 2x. Y plus a negative y, these two cancel out, equals 7 plus 9 is 16. And now you divide both sides by 2, and I find out that x is 8. Well, now that I know what x is, you can choose whichever equation you like best and plug it back in. So I'm going to use the first one, x plus y equals 7. So since x is 8, I'm going to replace x with 8. 8 plus y is 7. So now I'm going to subtract 8 from both sides, and y equals -1. So that means my solution is 8, -1. And you're done. Okay, so when you look at your two equations together, you always want to look at the x's and y's. The whole point is to get one of them to be positive and one to be negative, but they have to have that same number in front of them so that they will cancel out. Okay, so let's look at some other examples. All right, so here we have this one. So now notice that you have 6x minus 3y, and then you have 4x plus 5y. Well, in the first example, it was super easy because one was a negative y, one was a positive y. They already had the same number in front. Well, when you get them like this and they do not have the same number in front of them, I'm going to separate them a little bit. When they don't have the same number in front of them, it doesn't make it more difficult, so please don't think that, but it is an added step, okay? So what I do is I always look, okay, both of my x's are positive, but my y's, one is negative and one is positive, but they don't have the same number, so I'm going to have to do something extra. So what I'm going to do is I'm going to take this equation and this equation, and I'm going to multiply this equation here by 5. I'm choosing 5 because that's what's in front of the y value. So when I multiply everything by 5, so I'm going to distribute that 5 to everything. So I get 30x minus 15y equals -15. This equation I'm going to multiply by 3, okay? Because when I multiply everything by 3, you're going to see what's going to happen. 4 times 3 is 12. 3 times 5 is 15. And 3 times -9 is -27. So now I can add these two new equations that I created because I have a negative and a positive 15. So now just add 30 and 12 is 42x, and -15 and -27 is -42. And then we're going to divide both sides by 42. Cancel, and that's -1. So now I know that x is -1. So now you can choose either one of your equations again. I'm going to choose the second one because it really doesn't matter. So 4x plus 5y equals -9. And I'm going to replace x with this -1 that x is equal to. 4 times -1 plus 5y equals -9. So I get -4 plus 5y equals -9. So I'm going to add 4 to both sides. Try not to scroll up too much because I got my answer down there. So 5y equals -5. And then divide by 5 because that's what's in front of y. So y equals -1. So our solution, x is -1, y is -1. So that means that these two lines intersect at -1, -1. And, well, that wasn't the total answer. Sorry about that. So if the numbers don't already match, basically what you do is you manipulate it to make them match. And then you can get your answer, okay? So starting here, so you start here. Well, did I not just press to change the color? There we go. So you start here. Oops, no, we started here, and then we started solving here, and then you're able to get your answer. So it's really 3 parts. So pick your numbers that you're going to multiply by to make the variable cancel out. And then you just add the 2 equations together. And when you add them together, which is where they're getting the name addition method, you eliminate a variable, which is why it's also called elimination. All right, so let's try another one. So let's make this a little bit bigger. All right, so what I do here is I look at the 2 equations. So I look at these 2 and I see that I have this is a 1 right here. So I have 1x and -3x. Then I have -3y and +9y. So again, I'm going to want to multiply my 2 equations by something. And it doesn't matter because since this is positive and this is negative, or this one's negative and this is positive, doesn't matter which one you want to eliminate. So I'm going to eliminate the x this time, just for fun. So I'm going to take this first equation and I'm going to multiply by 3. And I'm choosing 3 because 3 times 1 will give me 3, okay? So that's going to be 3x minus 9y, 3 times 1, 3 times 3, equals, and then 3 times this, don't ever forget this side over here, -6. So I don't have to multiply this one by anything because it already has a -3. Okay, and now we're going to add them together. So 3x minus 3x is nothing. So you got 0. -9 plus 9, well, those cancel out too. So you have nothing on this side, and you have a -1 on this side. Well, since all of my variables canceled out, and this is not true, this is false, then that means these are parallel lines. Okay. Oops. All right. All right. So when it's false, remember, oops, parallel lines. Sorry, I had to step away for a second. All right, so here we go. Let's do it again. I found a few more extra examples this time. All right, so now let's solve this system here. So we have 2x plus 5y equals equals 1, and -4x minus 10y equals -2. So again, this is a positive and a negative. This is a positive and a negative. So it doesn't matter which one you choose. Let's just go ahead and multiply this first one. I'm going to multiply by 2. All right, and the reason I chose 2 is because I can multiply this 2 by this 2 and get this 4. So the goal is to always get the same number, okay? So when I multiply across, I'm going to get 2x plus 10y equals 2. So then sorry, this is a 4, not a 2. 2 times 2 is 4. 2 times 5 is 10. 2 times 1, 1 is 2. So this is a 4. That's a terrible 4. So our other equation is negative 4x minus 10y equals negative 2. So 4 minus 4 cancels. 10 minus 10 cancels. So there's nothing left on this side. And 2 minus 2 is also nothing. So now when it's true, when all of your variables cancel out and you're left over with a true statement, remember these are your coincident lines. So this is the same line. So that means there are infinite solutions. Should have went back here. I forgot to mention that here when it's false and it's parallel lines, remember that means no solutions. Sorry, I just kind of whizzed past that. Okay, so let's look at another one. So now we have 4x plus 5y equals 14, 3x minus 2y equals negative 1. So here I look and I see both of these are positive, but I have one positive and one negative. So I am going to choose to work with the y values because one is positive and one is negative, okay? So I'm going to take the first equation and I'm going to multiply it by this 2. So I get 8x plus 10y equals 28. And then I'm going to take the second equation and I'm going to multiply this equation by 5 because of this 5 right here. So now I get 15x minus 10y equals negative 5. So now I'm going to add the two together. So these y's will cancel out. So 8 plus 15 is 23x, and 28 minus 5 is 23. And if we divide both sides by 23, we get that x is 1. Well, now that I know that x is 1, you can choose either equation and you plug the 1 in. I'm just going to choose the first one. So 4 times 1 plus 5y equals 14. 4 plus 5y equals 14. I'm going to subtract 4. 5y equals 10. Divide both sides by 5. Y equals 2. So my final solution is x is 1 and y is 2. And make sure that you're careful which one is your x and which one is your y when you're plugging it in. Okay? So your final solution, and I will highlight that. Final solution. All right, so steps. Rewrite each equation in standard form. If necessary, multiply one or both equations by a non-zero number so that the coefficients of the chosen variable are opposite. So you want one to be positive, one to be negative, but the same number. Add your equations together. Find the value of one variable by solving the equation from step 3. Find the value of the second variable by substituting it in, and then check your answer. All right, so what happens when there is fractions, okay? So let me see if I can get this to be a pen now. Well, I guess it would help if I actually click the pen. Okay, so now what happens when there is a fraction? So let's look at what happens when there's a fraction. All right, so what you're going to want to do, you're going to multiply both sides of the equations by a number that will clear the fractions. So we're not going to work this out as fractions because nobody wants to do that. So we're going to take both equations and we're going to multiply them both by a common denominator. So if you look at all three of your, or look at all your denominators, we've got a 3, a 4, a 2, and a 4. So what is one number that will go into all of them? So 12, okay? So what I'm going to do is I'm going to multiply this whole equation by 12, and I'm going to multiply this whole equation by 12. So I'm going to get rid of the fractions first and then see what happens, okay? So 12 times 2 over 3x plus 1 over 4y equals negative 3 over 2. All right, so 12 times 2 is 24. 24 divided by 3 is 8. 12 times 1 is 12. 12 divided by 4 is 3. 12 times 3, negative 3, is negative 36. Negative 36 divided by 2 is negative 18. So now this first equation is really equal to this. Okay, so make sure didn't leave anything up. Okay, so now we're going to do the same thing with this equation, and let me change colors because I'm kind of cramming it in space, and I am sorry about that. So now we've got 12 times 1 over 2x minus 1 over 4y equals negative 2. All right, 12 times 1 is 12. 12 divided by 2 is 6. 12 times 1 is 12. 12 divided by 4 is 3. And then 12 times negative 2 is negative 24. So now we have our two equations here. So I'm going to add those two together. So let me stack them. I'm going to come over here and write them together. So now I've got 8x plus 3y equals negative 18. And then I have 6x minus 3y equals negative 24. So now I took the two ugly fractions in these equations and I made them whole numbers, so it's easier to work with. So I can add them together now because I have a positive and a negative 3. So I'm going to cancel those out. So 8 plus 6 is 14. And negative 18 plus negative 24 is negative 42. And we're going to divide both sides by 14. And negative 42 divided by 14 is negative 3. So now I know what x is. So now you're going to take that and you're going to plug it back in. If you want to plug it into one of these fractions, you're more than welcome to, or you can choose one of these two equations here. I'm just going to choose the first one just because that's just consistent. So 8 times negative 3 plus 3y equals negative 18. So I get negative 24 plus 3y equals negative 18. So I'm going to add 24 to both sides. Starting to get some lag. Sorry about that. So 3y, so negative 18 plus 24 is 6. We're going to divide both sides by 3. And we get that y is 2. So our final solution, they intersect at negative 3 and 2. Okay. All right. So this one, just real quick, if you look, always look at the variables. So we have a 6 and a negative 1, but then we have a 4 and a negative 4. So these two are already good to go. We don't have to make any changes. The 4s are going to cancel out. 6 minus 1 is 5. 8 plus 12 is 20. Divide by 5. X is 4. Choose an equation. Let's go 6 times 4 plus 4y equals 8. 24 plus 4y equals 8. Subtract 24 on both sides. 4y equals 8 minus 24 is negative 16. Divide by 4. Y is negative 4. Final solution, 4, negative 4. That is their point of intersection. All right, let's see if I pulled another one. All right, so here is one. And what I want to do here is I want to eliminate the y's in this one because I want to show y'all what happens when Like, what if they were all negatives, or what if they were all positives? Okay, all the examples we've done, there's always been one positive, one negative. But what happens, like I could eliminate the x's here and make this one really simple, but I'm going to take it and let me just make sure. Okay, yeah, that's my last example. So yeah, I definitely want to make sure I show y'all this. Okay, so I'm going to pretend that these are opposites of each other. Normally I would just multiply the first one by 4 so I can get 12, but we're going to pretend that this part is not simple. What happens when both of the signs are the same? The whole point of eliminating them is to make them opposites, right? So what I'm going to do here is I'm going to take this first equation and I'm going to multiply by -3, okay? Because that's a -3. But the second equation, I'm going to take and multiply it by +4. Because if I multiply it by a -4, they're both going to become positive. I need one of them to stay negative, okay? So the first equation is going to be negative times negative, so that's going to be 9x plus 12y. -3 times this is, sorry, -3 times -5 is 15. Now the second equation, 4 times 12, this is 48x. 4 times -3 is -12y. So see what I did? I multiplied this one by negative so that I could get these negatives to cancel, but I multiplied this one by a +4, the second equation by a +4, so that I could keep my negative sign so I can make them cancel, okay? So now I've got -18 times 4. So -18 times 4 is -72. So now I'll see how I got those to cancel out by doing that. So sometimes you'll multiply by opposite numbers. Sometimes you'll multiply by a negative opposite number, whatever. So we've got 48 plus 9. So this is 57x. And then we have 15 minus 72, which is -57. And then we'll divide by this 57 to make these cancel out. X is -1, okay? And like I said, you can plug it into either equation. I'll plug it into the second one. So 12 times -1 minus 3y equals -18. So see, it doesn't matter which one you plug it into. So we get -12 minus 3y equals -18. So I'm going to add this 12 over here. So -3y equals -6. Divide both sides by -3. I get that y is 2. So my solution is -1, 2. Okay, so hopefully you have a chance to watch this before we meet on Thursday at 7 o'clock. I'm going to get the last one made and posted for you by tomorrow. And it's just taking all 3 methods, and you kind of get to choose which method you want to use and apply it in word problems. So I'll see you guys on Thursday.